A manifold is any space which, if you zoom in close enough, just looks exactly like flat, what's called Euclidean space. Normal space that you learn about in school, a line, a plane, three-dimensional space, and so on. When you zoom in close enough, you can't tell the difference between any two manifolds. But when you look at the global structure, zoom out, look at the whole manifold all at once, they can have wildly different properties. A one-dimensional manifold, or a one manifold, would be a manifold where at every point I can zoom in and it looks just like a line. One example would be a circle. A circle isn't a line, but if I zoom in really close, it looks like a line. Two-dimensional manifolds are much easier to imagine. They're surfaces. Things like the boundary of a ball is called a sphere. The sphere, like the surface of the Earth, is a two-dimensional manifold because even though the Earth is not flat, it's very difficult to tell that. If you zoom in really close, you can only see a very small portion of the Earth. It looks exactly like a flat plane. It's like, let's say you're an ant and you're sitting on a basketball. At any point, I can go forward, backward, I can go left, right, and that's it. You can't tell that that surface is not just flat and goes on for forever. In contrast, a three-dimensional manifold is more like the space we live in now. We're all living inside of a three-dimensional manifold. At least I can only see a very small portion of the universe, and it's very hard to tell if it's just real space that goes on for forever. But that does mean that it is a three-dimensional manifold, even if it's hard for me to know the global structure of it. And so it's three-dimensional because at any instant, there are three different perpendicular directions that I can move in. I can go forward, backward, I can go left, right, and now I can also go up, down. So that's different from two-dimensional space. A four-dimensional manifold is like our three-dimensional space, except there's a new perpendicular direction. So in a four-dimensional manifold, starting at any point, you can go forward, backward, you can go left, right, you can go up, down, and now there's a new dimension that I don't have a good name for, something like forward and backward in time. And it's totally perpendicular to space. It doesn't change your position in space. Imagine you're in a movie, and this is time zero. The movie hasn't started yet. You have this three-dimensional space around you. And now you have your remote control, and you're going to press play on the movie, and you can see in the bottom of the screen the time of the movie, the run time. So right now it's time zero, but time is going to start increasing. And so if you pause at any moment, you still have a three-dimensional setting, but now that time value has changed. This is actually a four-dimensional space because time is itself a different direction. So a four-dimensional manifold is any object that locally, if you zoom in close enough, it looks just like standard four-dimensional Euclidean space.